Hi everyone, welcome back to the course manufacturing process. Today in this part we are going to discuss about sheet metal working. Have you ever thought about how the car body is produced, how the airplane is made, especially the body of the airplane, how the railway cars have been made, small and large appliances, these are by sheet metal working. So what are the different types of sheet metal working processes? They are cutting operations, bending, drawing, other sheet metal forming operations. And then in this chapter, in this chapter and the coming chapters, we are going to discuss about dies and presses used for sheet metal processes, sheet metal operations, bending of tubes, etc. So sheet metal working. What is sheet metal working? Cutting, these are cutting and forming operations on thin sheets of metal. Cutting and forming operations on thin sheet of metals. Changing the shape of the thin sheet of metal. Sometimes we have to cut the metal, sometimes we have to change the shape, we have to bend it, etc. These processes generally we call them as sheet metal working processes. So normally sheet metal, we call them as sheet metal working if the stock thickness ranges from 0.4 mm to 6 mm. Stock thickness means thickness of the sheet. If the thickness of the sheet is greater than 6 mm, we call it as plates. Operations usually performed as cold working. As you know, cold working, the strength will be very high compared with hot working process. And you can see the products produced by sheet metal working, they are automobiles and trucks, airplane bodies, railway cars, then farm and construction equipments, computers and office equipments, etc. What are the advantages of sheet metal working? They have high strength, good accuracy, dimensional accuracy, good finishing, and they have relatively low cost and economical mass production for large quantities. How do we produce them? What are the methods? So by using punch and die method, the tooling used for punch and die, this can be used for cutting, bending and drawing processes. Stamping press is a machine tool that can be used for stamping operations, etc. Metal cutting process, as I explained before, just using a sharp edged metal edged cutting tool, or by using a by using a punch and die, cut the material. Whenever the force reaches above its shear strength, the material shear dh will be equal to the whole diameter in the case of punch and die system. Now, what is angular clearance? Angular clearance is the clearance given to the die to drop the blank or the slug through the die. It is the angle like 0.25 degree to 1.5 degree given to the dies. This will facilitate, or this will allow the material to drop through the die. So how do we calculate force? Force can be calculated as STL. How much is the force to cross the shear strength of the material and to produce shearing operation? So the force required is equal to, it has to cross shear strength, of course, shear strength times area. Area is T, the thickness of the material thickness, times L is the length of the cutting edge. So length of the cutting edge times T becomes the area of cutting, times the shear stress or strength will give you the required force for cutting operation. Normally shear metals bending, as you see here, the material, if it bends like this, the inner surface will be under compression and outer surface will be under tension. So this is this already we studied in strength of materials. Whenever a metal bends, the outer surface bends more, it will be under tension, and the inner will be compressed, it will be under compressive stress. The neutral axis it will get unaffected. It will neither be under tension nor be under compression. Now if you take the bending operation, we have two types of bending operations. First type is V bending, where we use a V die and the material is placed over it. A punch which has a shape of V, it is used for the deformation. The material will get squeezed, compressed, and plastic deformation takes place. Material material's shape will get changed. This is called a V bending process, where we use a punch and die which has a V shape or required shape and angle. So they are normally inexpensive. Now if we have a second type called edge bending, here the shape is V, but in the edge the shape is somewhat like a square. So here the punch and die, there will be a clearance between them. The clearance will be given in such a way that there will not be any shearing, and the material will bend only. So we make sure that the material will not shear, and we make sure that the material will undergo bending only. So we use a punch and die, and a sufficient clearance or clearance should be selected in such a way that there will not be any shearing, and the material will undergo only bending operation. So when the punch descends, what happens? Material will undergo plastic deformation, compression takes place, and we get a square shape which is called edge bending. So stretching during bending, actually what happens is, when we bend a material, the material outer surface will bend more, inner surface will bend less. So when we bend the process, when we undergo bending operation, we should select the length of the stock before the operation, because after bending, for example, if after bending, if we need 100 millimeter, and if we select a stock of length 100 millimeter, we will not get 100 millimeter exactly. So the final part length should be selected according to certain principles, so that the final length should be equal to the specified dimension. So how do we do that? We need to use a bend allowance for that has to be added. So as you know that when we bend it, after bending, when you measure it, the length will be less. So length will be less, so you have to add a bending allowance for that. That bending allowance can be calculated using the equation 2 pi alpha is the bending angle divided by 360 times r is the bending radius, plus kba is a factor to estimate the stretching, times t is the stock thickness. Kba equal to 0.33 if r less than 2 times thickness, r greater than 2 times thickness, the bending constant can be taken as 0.5. So this bend allowance we need to add to the work part before bending to get the required specification or dimension of the final part. Now spring back, when we bend a material or a sheet using V bending technique, as you could see here, after the process, you can see here the bending angle is alpha b dash and the radius is r bar b. When the punch is removed, due to the elastic energy stored by the material may return back slightly. That effect is called spring back, and the angle is alpha dash. So after it comes back, the angle is alpha dash. So how we calculate spring back? That is equal to the final angle alpha dash minus the initial angle, which is alpha b dash, divided by alpha b dash. This will give you the spring back. This is because of the elastic energy stored by the material, and that will be restored. The material will try to come back. That's why there will be a slight spring back effect in the material itself that we can calculate using this equation. Select D here, and then we can calculate the required bending force. Thank you very much for listening. Thank you.